have a ruler in your blue bucket. There should be some like protractors in there. Okay, there's not enough for everybody to share. Okay. Alright, we are checking off the properties that are going to apply to rectangles. Okay, some of it's common sense based off just our knowledge. Okay, so opposite sides are congruent, yes or no?
Yes.
Yes. Are the opposite angles congruent? Yeah, because what are all the angles of a rectangle?
90 degrees.
90 degrees. Diagonals bisect each other?
Yes.
Yes. Opposite sides are parallel?
Yes.
Yes. Okay, so we know for sure that it has those properties of a parallelogram. Okay, now let's see about the additional properties. Are all four sides congruent? No. All angles right angles?
Yes.
Yes. Diagonals congruent?
Yes.
Okay, measure real quick and make sure. Are the diagonals congruent? Are we good or no?
Yes. Yes.
Okay, why else would the diagonals be congruent? Or why else?
Because it's like the same rise over a run.
Okay, it has the same rise over run, or it's going to make the same right triangle, because this is a width and a length, okay, and so your hypotenuse would be the same measure as the width and the length hypotenuse on this side, okay. You're always going to have a width and a length as your two legs. Okay, are the diagonals perpendicular? Look at your picture. Does it look like they form right angles when they intersect? No. Okay, do the diagonals bisect the opposite angles?
No.
Use your protractor. Do they bisect opposite angles? Basically, what you would be telling me is that both of those angles are 45 degrees at each corner. Using your protractor, what do you find?
They are not.
They are not. Okay, the opposite angles are not bisected for rectangles. Okay, I think this one is like 60 something or 70 something, and this one's only like 20 something. Okay, so there's 6 properties. Okay, and then we have some more to add in a second. But determine how many lines of symmetry and describe where they are located. So where are our lines of symmetry? So think about your paper. How do you fold this and make symmetrical sides? A hot dog and a hamburger. Okay, so you have 2 lines of symmetry, vertical and horizontal folds. Okay, and again, what do we call the figure in figure 1? A rectangle. Okay, so by definition, a rectangle is a parallelogram with 4 right angles. So it's going to have all the properties of a parallelogram and the ones that we checked above. So, this would be the type of question. All rectangles are parallelograms would be true, but are all parallelograms rectangles?
No.
No. So those are the type of questions. Okay, sometimes they are, but that word all makes it false. Okay, properties. So it has all properties of a parallelogram. but the diagonals are congruent, and there are 4 right angles. Oh, sorry. Okay, so not only are they bisected, but they are also congruent, which means that you're creating 4 isosceles triangles. Okay, for ways to prove if it is a rectangle. If it is a rectangle, then there are 4 right angles. And then the other way is if the diagonals are congruent, then it is a rectangle. Okay, if you cannot prove either of those 2 things, then it's just what? A parallelogram. Okay, so you have to take it a step further in order to prove it's a rectangle by proving one of these 2 things. Okay. Pink table. Fill in column number 2. Fill in column number 2. You'll actually have 10 things. Again, you should have 10 boxes shaded or checked or whatever. Okay, so looking at our rectangle, I'm just going to go back to the front. Okay, I'm going to go down my list. Opposite sides parallel? Yes. Opposite sides congruent? Yes. All sides congruent? No. Consecutive sides congruent? No. Opposite angles congruent? Yes. Opposite angles supplementary? Yes. Why? 90 and 90. Okay, so because there's 4 right angles, 90 and 90 will always make 180. Consecutive angles supplementary? Consecutive angles congruent? All angles are right angles? Diagonals are congruent? Diagonals are perpendicular? No. Diagonals bisect each other? Diagonals bisect opposite angles? No. Diagonals form 2 congruent triangles? Yes. Very good. So those are our 10 things. Alright. ABCD is a rectangle. AB equals 2x plus y. BC equals x plus 2. DC equals x equals 12. I think that should be x plus 12, sorry. Should be x plus 12. And AD equals y plus 6. find AB. Okay, so draw your rectangle. Same thing. You need to pick a point and go clockwise or counterclockwise. You can't just jump around everywhere. Okay, AB is 2x plus y. BC is x plus 2. DC is x plus 12. And AD is y plus 6. So what do you know? Okay, so you know 2x plus y equals x plus 12. And what else do you know?
Y plus 6 equals x plus 2.
Y plus 6 equals x plus 2. X plus, yes, 2. Okay, so how do you want to proceed, Miranda?
Isolate y in the first equation and then plug it in.
Isolate y in the first equation, okay, and what do you get?
Wait a second. Y equals x minus.
Oh, so you're doing this one?
Oh.
That's fine. Y equals x minus 4. Okay, and then you're substituting that in to your second equation. Okay, so I have 2x plus x minus 4 equals x plus 12. So I have 2x plus x minus 4 equals x plus 12. I have 3x minus 4 equals x plus 12. I combine like terms. I have 2x equals 16. So what does x equal?
8.
X equals 8. How am I going to figure out what y equals?
Plug in 8 for x and the y equals 8
Okay, so y equals 8 minus 4.
y equals 4.
Y equals 4. So how do you find AB?
Plug in x and y values.
So I have 2 times 8 plus 4.
Equals 20.
AB equals
20 units.
20 units. Question on the system.
Are you going to take off points if you don't put units?
Not on a problem like this because there wasn't any, but yes, if there was some. Okay, 2. GINA is a rectangle. Find each of the following, A, B, and C. Okay, what would be the length of XA?
5.
5. How do you know that?
Okay. I've got 8.
It's an isosceles triangle, but your diagonals are not only congruent, but they're bisected. Okay, so if this is 5, all these pieces have to be 5 as well because they're bisected and congruent. Okay, so XA would be 5. GNI would be what?
168.
78. Why 78?
Oh yeah.
Not alternate interior, but this right here is an alternate interior, which makes this 12. And you know that this is a right angle, so 90 minus 12, and that's how you would get 78. Okay, what about NAI? Why is it 12? Very good. It's an isosceles triangle, and base angles of isosceles triangles are congruent. Very, very good. Questions on that? Okay, so now do you see why opposite angles are not bisected? So this is an example right here. You've got 78 and 12. Okay, so opposite angles are not bisected necessarily. Okay, so for 3, find the values of all the variables. What is H? 110. What is G? 70. Okay, what else do I know?
K is 55.
How do you know that K is 55?
Because the triangle is supposed to be 180 degrees, so
Okay,
subtract and divide by 2.
very good. So, you know that it makes up 4 isosceles triangles. Okay, you know that the base angles have to be congruent. So if I take 180 minus 70, that's 110 degrees left over, and that has to be divided equally into my base angles. Okay, and that's why it's 70, 55, and this would also be 55. Okay, so same idea to find F. You know this is an isosceles triangle, so this base angle is congruent to this base angle. So if this is 110, I need 70 degrees split evenly in my base angles, so what is F?
35 degrees.
35 degrees. Okay, so the whole idea of isosceles triangles is huge for rectangles. Okay, you'll need that idea for probably a majority of your homework problems. Okay, so make sure you are aware and know how to use isosceles triangles. Okay, another system, ABCD is a rectangle. AB is 2x plus 14. DD is 4x minus 12. AD is 9. It wants us to find AB and AC. Okay, how can I solve for x?
2x plus 14 equals 4x minus 12.
Very good. 2x plus 14 equals 4x minus 12. Subtract 2x. 14 equals 2x minus 12. Add 12 to both sides. 26 equals 2x, so what does x equal?
13.
Okay, so what do you know about the side AB? 39.
40.
40.
Uh-huh.
Okay, so you know this is 40. This is 40. Okay, so how can we find AC?
Hypotenuse theorem.
Not hypotenuse theorem, but Pythagorean theorem.
Yes.
Okay, so you have 40 squared. I'm running out of room, but 40 squared plus 9 squared. Take the square root of that.
41.
41. What would be the length of BD?
41.
41, because diagonals are congruent. Alright, good old proof time. Woo! Statements on the left. Reasons on the right. Okay, you're starting with a given. I'm not going to rewrite all that. I'm just going to put some dots. Okay, but rectangle RECT with diagonals RC and ET intersect at point A. Prove that RCT, so this big triangle here, is congruent to ETC, so this triangle. Okay, so somebody give me something that we know based off the fact that this is a rectangle. RTC is congruent to...
RTC is congruent to TCE.
Very good. Angle RTC is congruent to ECT. Why is that? Before you can say that, though, how do you know that those are right angles? Property of rectangles. So having 4 right angles. Okay, so we have an angle that is congruent in both. What else? RC is congruent to ET. Why is that? Very good. Diagonals of rectangles are congruent. Make sure you explain like what property it is. That's why I said 4 right angles. That way I at least know that you know what you're talking about.
We do have to.
Because it's really easy to say property of rectangles, but maybe not even know the property. Okay, so now I know that this is congruent to this. I have an angle. What else? RT is congruent to EC. It's not going to help us because that's going to give us SSA. Yes. 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 I just went a different way for HL, but yeah. What'd you say? RT is congruent to EC. With that kind of same mindset, the HL theorem, what else could you have said? What else do they share? TC. So you could have said TC is congruent to TC because of reflexive, because they both overlap that piece. But RT is congruent to EC. That's fine. And why is that? Oops, opposite sides of rectangles are congruent. Or you could have said, like I said, TC is congruent to TC because of reflexive. Okay, and then last but not least, what do we have? Not CPCTC. Remember that when you're talking about congruent, yes, you have to have a theorem. HL congruency theorem.
Could you also prove side angle side?
Yes, if you never did the diagonals, but you did this and this. Yes. Alright, next page. Consider each LED television shown. Determine the dimensions of the 27-inch. So, hopefully you have your calculators and some good old trig to throw at you. Okay, figure out X and Y for the 27-inch for letter A and for the 30-inch in letter B. So, figure out X and Y. Make sure you're in degree mode. Round to the nearest hundredth. That's what I did. Go on to letter C once you figure out the dimensions. 600. I hear everything.
Can you second to finish letter C?
Okay, what were the dimensions of a 27-inch TV? X equals 13.25 and Y is 23.5. Is it 2 or 3? 2. And we are in inches. Did y'all know that TVs were measured by the diagonal?
No, no, I didn't.
You didn't know that?
Yeah, I didn't know that.
I don't think I knew that until college, honestly. So it's okay if you don't. Yeah. See? Yep. It's the diagonal. Okay. What are the dimensions of the 30-inch? X equals 15.90 inches and Y is 25.44 inches. Okay, compare the viewing area for each TV screen. So the 27-inch TV screen has an area of what?
311.64 inches squared.
And the 30-inch?
404.50.
404 point what? 469?
469. I think 49.
496, that's 50.
Oh, sorry.
Okay, so 50. Okay, good. Okay, very good. So obviously, the larger the diagonal, or the bigger the diagonal, the bigger the TV and the viewing area gets. Okay. What property of a rectangle would be helpful when locating the center point of a television screen? Very good, that the diagonals bisect each other. Because they will bisect at the center. And last but not least, I think, yes, letter E. What property of a rectangle would be helpful in determining the perimeter of the TV screen? Very good. that opposite sides are congruent. Okay, turn over your notes and your pink sheet. Let's see if we know our properties. Okay, we're going parallelogram first. Somebody tell me a property of a parallelogram. Opposite sides are congruent. Opposite sides are parallel. Consecutive angles are supplementary. Diagonals are bisected. Did we say that one yet? Opposite angles are congruent. And what else? Diagonals make two congruent triangles. Very good. Okay, so we have those 6. Okay, we added 4 more with the rectangles. And what are they?
All angles are right angles.
All angles are right angles. Consecutive angles are congruent. Consecutive angles are supplementary. Oh, we already have that one. I like. Opposite angles are supplementary. And the last one, pertaining to diagonal. Okay, we have that because that was the property of the parallelogram. Have that because that's the property of a rectangle. Parallelogram. We're missing the one about diagonals. They're congruent. Diagonals of your rectangle are congruent. And so because they are congruent, it creates 2 sets of what? Isosceles triangles. Very good.